Today we're going to be talking about function continuity. What does it mean for a function to be continuous? Let's start with just sort of an intuitive visual definition. A function is continuous if you do not have to pick up your pen as you're drawing it. If you have to skip a point, if it jumps across an asymptote, or if it just jumps from one level to another, these are all discontinuous. A function doesn't have to be smooth to be continuous, but it does have to basically be uninterrupted. We have a more formal definition of what it means to be continuous at a particular point that will cover these cases and explicitly exclude these cases. There are three things that are required for continuity at a point A. So a function f of x is continuous at point A if, number one, the function at A exists, 2, the two-sided limit as x approaches A of the function exists, and 3, that this equals this. The function equals the limit value. Now, let's go through these in order. If the function doesn't exist at a point, then it's not continuous. So in other words, if you have a hole there or a vertical asymptote, that automatically excludes continuity. Okay, well, let's say the function exists, but the limit doesn't exist. Well, that would be something sort of like this case. Here, the function does exist. It's defined up here at x equals a. However, the limit doesn't exist. The function does not approach the same value from the left as it approaches the right. So it meets criterion 1, but fails criterion 2. Now, what does it look like if the function exists and the limit exists, but they're not the same value? Well, here the limit exists, the function exists, but if they're not the same value, you still have to pick up your pen as you're drawing the function. So this meets criterion 1 and 2, but doesn't meet criterion 3. Only in the case where all three of these are true, so I'm going to draw this as a hole that's filled, will the function be continuous. So the function exists at point A, the limit exists, and they equal each other at A. That's what it means for a function to be continuous at a point.